The problem doesn't read very well. I apologize for that, but we've got this boardwalk, and I'll draw it right here. We've got, and we've got um, a man standing on the boardwalk, and the boardwalk is 210 feet inland from water. Okay, so we got this water out here, and we've got. We'll put cam out. Cam's out. Oh, put your shark. There you go. Shark's coming. By the way, great movie, Jaws. First Jaws, classic. Gotta watch. All right, so it's 210 feet inland. Okay. A sandy beach lies between the boardwalk and the shoreline. A man is standing on the boardwalk exactly 750 feet across the sand from his beach umbrella. There's a beach umbrella right here. And he wants to get to his beach umbrella. Who wouldn't, right? It's right on the edge. You know, he's sitting there in the sand. If he wants to pop in the water, he can cool off or he could come back under his umbrella. Good life, right? Jack Pulley. Jack Pulley. He's in the Dominican Republic right now. Here's the problem for Jack right here. Okay. Well, the deal is that the man walks at 4 feet per second on the boardwalk and 2 feet per second on the sand. So how far should he walk along this boardwalk? He's going to walk on it for a while, and eventually he's going to veer off and head straight to the umbrella. And he wants to make it in exactly 4 minutes and 45 seconds. Now, that's just kind of stupid. I mean, who cares if it's exactly 4 minutes, 45 seconds? We would rather say, what's the optimal time? Like, could he make it in, say, 4 minutes, 20 seconds? We don't know how to do that yet because we don't know calculus. But we'll revisit this problem later on and figure out how to do it. Okay, what kind of problem is it? Say it. Distance equals rate and time. Rate times time. Very good. Now, what are we trying to get everything equal out to here? Are we trying to equal a distance? Are we trying to equal time? Are we trying to equal a rate? Trying to equal time. So I'm going to divide by r, and I get d over r is equal to your time. So if I would say that the time on the boardwalk plus the time on the sand, that should be equal to 4 minutes, 45 seconds. Right? Okay. A couple things I don't like about this problem right now. I don't like the minute seconds thing. How about you guys? So let's change it to seconds. How much is 4 minutes and 45 seconds? 485. 285. Because 4 minutes is 240 seconds plus the 45, 285. So first of all, this is equal to 285. Second of all, I know that the time is equal to the distance divided by the rate. We don't know the distance on the boardwalk yet, do we? But we do know the rate on the boardwalk. What is it? 4 feet per second. Plus distance on the sand divided by 2 feet per second. And that should equal 285 seconds total. Well, now the equation's taking much more shape. Now I just have two unknowns, distance on the boardwalk and distance on the sand. Looks like I need to insert a variable. And I'm going to choose, most people would choose this to be x right here. I'm actually going to choose this distance right here to be x. And you'll see why. I'm just trying to save us a little bit of work. I'll call that distance y. Wouldn't it be nice to know what that entire distance is, x plus y? Any idea how to figure that out? Pythagorean theorem. Namely that x plus y, or that distance squared, plus 210 squared is equal to 750 squared. So you should all have your calculators out so we can save time here. Do we need our calculator today? You need your calculator every day. So we have 750 squared minus 210 squared. Is that my answer for D? Nope, not even close. I totally messed that up. So 750 squared minus 210 squared. I get that. What do I have to do? Square root it. Square root the answer. 2 idiots. Second answer. There you go. Enter. 720. So this whole length here, this whole distance right here is 720. So if this is x, this is key. You got to see this. If this is x, what is y? Thank you. 720 minus x. Is that clear to everybody? Okay, that's the distance on the boardwalk. This red line is the distance on the sand, correct? I need to solve for that in terms of x. What will I use to solve for that in terms of x? What shape does it make? What do we use for triangles? Pythagorean theorem. So if we call that length c, c squared is equal to x squared plus 210 squared. What variable am I trying to solve for? C. How do I solve for c? Square root both sides. So c is equal to the square root of x squared plus 210 squared. Well, it's not pretty, but at least we have an expression. Let's write it out. What's my distance on the boardwalk? 720 minus x all over 4. Plus, what's the distance on the sand? Square root of x squared plus 210 squared. All over 2 is equal to? Now, getting an equation like that isn't the simplest thing in the world. And so, you've seen it modeled now, right? Question is, could you come up with it again on your own? Okay, Brooke says, no, I believe in you, Brooke. I believe in you, okay? So, not easy, but you can do it. The more you see it, the more you can do it. But now it's just algebra, right? And we all know how to solve this. What are you going to do first? Sure, so multiply through by 4. So if I multiply through by 4, I just got 720 minus x plus 2 roots of x squared plus 210 squared equals 4 times 285. 1140. Because I want to get rid of the fraction. So if I multiply this top through by 4, bottom will go away. 4 over 2 gives me 2 on top. And 4 times 285 gives me 1140. Multiplied everything through by 4 over 1. Now I got to get rid of the square root. How do I get rid of the square root? Square both sides. Before I square both sides, what should I do? Yeah, I got to get 720 over there, and I should get the x over there, right? So I have 2 roots of x squared plus 210 squared equals, what's 1140 minus 720? 420. And then add the x plus x. Now what? Square. 2 squared, 4. Times x squared plus 210 squared equals x squared. What are you going to get in the middle? 840. And then 420 squared, whatever that is. Sounds good. Multiply through by 4. 4x squared plus 4 times 210 squared equals x squared plus 840x plus 420 squared. What to do now, what to do now, what to do now? Who's got bright ideas? Why? They don't just go away, though, do they? I can move everything to the left and set it equal to, because then I can factor or quadratic formula. You have the quadratic formula on your calculator, right? So use it. So we subtract the x squared over, we've got 3x squared of a minus 840x. And then I got to do 4 times 210 squared minus 420 squared. So 4 times 210 squared minus 420 squared is 0. Awesome. So it looks like the 4 times the 210 squared, the 420 squared, they just canceled, right? It's pretty good. Factor. What can you take out? And a 3. You're left with? What's your solution here? What's your solution here? Is that our answer? Let's go back and interpret it. X is 0 or 280. That's where X is. The question is, how far should he walk before veering off? So suppose X was 0. How far should he walk? 720 feet. Now, that's the entire distance. Would walk the entire distance and then turn in, right? Or he has another option. He could walk 720 minus 280, which is, and if he were to just walk 440 feet and turn in, he would make it in the same amount of time. Now, I know that that looks, kind of ridiculous, a little bit large, a little bit, difficult. Every year, I have a number of students that they get this problem right on the test. So I put this on the test, but I give you choices of problems that you have to do. And so maybe on the test, for example, I promise you that you'll have to be able to do a consecutive numbers problem. You'll have to be able to do a mixture problem. You'll have to be able to do rectangles and shapes problem. You have to be able to do similar triangles problem. You'll have to be able to do a distance, rate, and time problem. You'll have to be able to do a work problem. But I'll give you a choice. So I won't just put 6 problems on there. I'll put, say, 10, and I'll say you choose 7. See what I'm saying? But, whether it's extra credit or whether it's one of the problems, this is one of the problems you can do. So your goal is to put yourself in a position where you can do as many of the types of problems as possible. And if you don't think problems like this are realistic, don't show up for my class next year, okay? Because, if you're ready for calc, we need to be able to handle problems like this. Does that mean you get it right on the first try? No, but it does mean that you should be able to take that problem home and you should be able to handle it on your study guide, working through it. So problem number 12 on your study guide, that follows similarly to this. And then look at your homework problems I gave you. So this is what I did for you. I gave you problem number 21. 21 is nearly identical to this problem right here. In fact, I took it out of your book, and your book shows you, it's an example problem in your book from section 1.6. It lays out step by step how to do it. So what you can do is you can look at problem 21. You can try it on your own. If you don't get it, you can check the book and see exactly how they do it, or you can come check my answer key up here because I've done the entire problem for you as well. Okay? So you have the rest of the hour to work. I have nothing new for you. I have the answer keys up there. Tomorrow, we will do a checkpoint at the beginning of class, and then I will make sure you know exactly the types of problems you need to do and how many problems you're going to be expected to do on the test. So good luck. Get ready. Go.